Hello, and welcome back to yet another retro channel. Today we're going to see if we can make any more progress with the TI-99 4A. Now, if you remember from last time, what we've done is we have cleaned up the spill that was a liquid spill into what appeared to be into the expansion port connector of the TI-99. We had a brown substance, which I was guessing was soda pop, but I have no idea for sure. We cleaned that using both a baking soda solution and then later with vinegar. And then we washed the board thoroughly, and we got most, but not all, of the corrosion off of it. Then we tested various things. We tested the power board with another working TI. It works fine. We're getting correct plus 5, plus 12, and minus 5 volts out of the connector. We tested the keyboard, but I don't think I showed that because it's really immaterial to what we're doing, but the keyboard does work. And then we began looking at the motherboard, connecting the motherboard up to the power supply and applying power. The first thing we noticed was that we got a black screen and a continuous tone out of the sound chip. Okay, and what that means is that the startup process, which we can take a look at, the startup process, which goes through several steps, before it reaches the point where it basically resets the sound chip to 0, up to that point, the sound chip will be playing sound from whatever is in its buffers at that point. So you get a random sound until the boot up process shuts it off. So we know that the sound chip is at least functional. We also know that because the next thing we did was we took the VDG, this 9918 video chip, and we took the 3 groms and the sound chip, and we put them individually into a working TI, and each of them worked. So we know that this chip, the 3 grom chips, and the sound chip, the VDG, the 3 groms, and the sound are all working. They're all good chips. So the next thing we did was we took a look at the power rails, and once I figured out that I was reading chips upside down, because this thing is kind of built upside down, most of the chips, their pin 1 indicator, their notch or their dot, is facing the bottom of the board. So you've got to make sure that you're accounting for that when you're looking at pinouts and trying to see things. We were actually getting the correct plus 5, minus 5, and plus 12 volts as far away as the last RAM chip. I also saw the voltages on a few other chips, so the voltages appear to be good. The next thing we did was we took a look at the clocks, and the TI-99 4A uses the TIM 9904 ANL clock chip to produce 4 12-volt clocks and 4 5-volt clocks. Those 4 clocks are each 90 degrees out of phase from each other. So 4 12-volt clocks at 3 megahertz, 90 degrees out of phase from each other, and 4 5-volt clocks at 3 megahertz, 90 degrees out of phase from each other. And we were not seeing those clocks on the 9904. So I desoldered the 9904 and put in a socket, and I put in this chip, which I had purchased. Now this is a TMS 9904 ANL, whereas this is a TIM 9904 ANL. And when we put this chip in, we were getting 3 megahertz clocks. No, we were getting 12 volt and 5 volt clocks, but the timing was not 3 megahertz, it was 750 kilohertz. What I have since deduced, and I can't find any explicit information on this, but what I have deduced, the earlier TI-99 4 and the early 4As used a 48 megahertz crystal here and used apparently the TMS 9904. There could have been some TIM 9904s that fit this, but these have two divide by 4 stages in them, whereas the TIM 9904, the later one, has only one divide by 4 stage. So the original chip would have required a 48 megahertz crystal here, and the new chip, the newer chip, the TIM 9904 ANL, takes only a 12 megahertz crystal, and this is a 12 megahertz crystal. So at the time, I did not have any other replacement 9904s, so I took a pot shot and I put the original 9904 into the socket. And I don't know whether it was a corroded connection or a cold solder joint or something, but when I replaced the original TIM 9904 back into the socket, I started getting correct clock signals. So we are now getting all 8, the 412 volt and the 45 volt clocks at 3 megahertz. They're all correct coming out of this chip. So we have clocks, we have power. Okay, so the next thing we need to do is start looking at some of the control signals. And in setting this up, the first control signal we're going to look at is reset. We need to make sure the board comes out of reset as it should. And in setting this up, I was, testing my setup and using reset. And while it was coming out of reset, I wasn't certain of the timing. When you switch the machine on, it should stay in reset for a certain length of time and then come out of reset. Unfortunately, on the TI, the minimum time that it's supposed to hold in reset is 4 clock cycles. And with the clock being 3 megahertz, that's a little faster than you can see by simply watching the signal. So what I've got hooked up here is I have both channels of the oscilloscope hooked up, one to the 5 volt and the other to reset. And what that'll allow us to do is to see on the scope whether there is a delay between power on and reset. And I'll try to catch that here on the scope. So I'm going to switch it on, and we should get a signal. Okay, so there you can see the green line is the 5 volts and the yellow line is reset. So you can see that there is a short delay between power on and reset. So our reset circuit is good. Pin 3 is the wait signal, and wait is an output from the CPU indicating that the CPU is waiting for the external memory system to be ready before continuing. I'm not sure what I should see on that when I power this on, but we'll see if we get any activity at all. Okay, wait is active high. Let's do that again. We got some activity and it looks good. It's clean. It's not being held halfway through, so I think we're good there. The next signal is load, which is active low. When this is active, it's going to activate a non-maskable interrupt with a specific memory address. So I'm not sure if we're going to get any activity on that on power up either. So we'll check it. It's staying high, so it's not executing a non-maskable interrupt there. So we'll call that good for now. The next signal is active high, and it is called hold A, and it's an output from the CPU acknowledging that the CPU is in a hold state waiting for the completion of a memory cycle. So again, I don't know if we'll be seeing anything on this on startup, but we'll hopefully be able to tell if it's being held, in a bad state, halfway high, halfway low, or something like that. Okay, hold A is active low, and it's low. So it looks like it's waiting for some kind of memory activity to go on. So we'll move on from there. So next pin's reset, and then after that is IAQ. IAQ is an output signal indicating that the CPU is waiting or is acquiring an instruction. Again, this is active high. So we're never waiting for an instruction. I don't think we're getting that far. The next two pins are the Phi 1 and Phi 2 12-volt clocks. We know those are good already. And then we start getting into the address bus. 4, 5, 6, 7, 8, 9. Pins 24 through 10 are the address bus. Now there are some quirks about the address bus on this machine and how it talks to some of the other ICs. So we'll get into that in a bit, but let's just check and see if we're getting good signals on these address lines. This is address line 14. Those signals looked good. 13. Yeah, we're getting good strong signals there. 12. That was a good strong signal there. 11. Good strong signals there. Nothing being held down. 10. Okay. 10 does not look great. It looks partially okay. I mean, we're getting up to 5 volts, or near 5 volts, but all that random slop in that signal I don't like the look of. So I'm going to write down that we have something going on with address line 10. Nine. Okay, that one's being held halfway. So something is fighting address line 9. Address line 8. Same thing. Address line 7 looks good. 6 is being held down. 5 looks like it's being held down. 4, yep, that was also a mess. 3, 3 looks pretty good. 2, That's address line 2. Address line 1. Looks relatively good. And 0. Yeah, that's a mess. Okay, well, we have some big problems with the address lines. This is concerning because the only thing that I know of that's on all the address lines is the CPU. So if it's true that our CPU is having a problem, we're going to have to replace that. I do have a spare. I was hoping that a 0, 1, and 2 would be good. That would indicate that the problem was most likely with one of the ROMs, because the ROMs are connected to address lines 3 through 14. The 2 little scratch pad RAMs are attached only to address lines 8 through 14. So finding that the problems were in those areas, in those regions of address lines, would have given us a pointer to something that was bad. But since we've got bad on address lines across the board, I'm concerned that our big problem is the CPU. In my reading, like I said, I don't think anything else is connected to all 15 address lines. And just so you know, that's another oddity of this machine. It's a 16-bit data bus. It's a 15-bit address bus. So, like I said, TI managed to hobble this potentially very powerful 16-bit machine in many ways. So, I think our next step might be to go ahead and, wow, I hate to do this, but our next best step might be to replace the CPU and see if we get any improvement. So, I guess we start up the desoldering iron and get ready to do some chip removal. I'm going to go ahead and add a little leaded solder to help me get this out. Okay. And we'll be using some flux. Okay, let's see how we're doing. Pretty good so far. There we go. There we go. I went ahead and pulled these two wires. These aren't bodges, these are actually known to go on the board, or known to be part of the design. But got them out of the way so that I could get the CPU out. I don't see any physical damage to the CPU, but that doesn't mean it's not bad. So set that to the side, and now, because I did watch Adrian Black's video, and I know what can happen, I'm going to use some UV curing solder mask to protect any traces that go between the vias. I'm going to have to bring in my magnifier here so I can get this right. So apologize for the view being bad. But I've got to make sure that I get these traces that go between the vias protected. First, let's just clean that up with some wick. We'll not only take off the solder, but hopefully it'll take a little of that remaining corrosion off. That may, of course, be an issue. Yeah, it does look a lot cleaner. We'll go ahead and do that to both sides of the board. Start applying some of the solder mask. I'm just going to use a toothpick because we've got very small areas to work with. That is by no means going to make it impossible to screw up, but it should make it less likely. So, while that finishes setting up a bit, I'm going to take a quick break and take the dog out, and I'll be back and see about installing some pin headers. See you in a few. Okay, sorry about that. I forgot to start the recording. I have gone ahead and soldered in the pin headers. Or the socket headers, I should say. I used pin headers to hold them in position, and blue tack so they'd be aligned and positioned properly. I soldered them in, and now I am going through and checking for any bridges to the vias, or to the traces that go between the vias. Okay, I think I got all the through traces checked. Now I'm just going to check for, well, there are a bunch of bridges that are intended to be there. So we're going to have to trust at this point that I got those incorrectly. Now, so the replacement 9900 that I purchased, I have no idea if this works. I have no way to test it, as this is the only board I now have with a socketed CPU. This one's in very good shape. It looks like it may have never been installed, so we may be in luck here. Let's a little pin forming and see if we can get this seated. These are notoriously hard to get placed, and the milled pins won't help any. Okay, I've got those two shunt wires back in place, and I think we're ready to take this thing on a little test run. The new CPU is in place, so we have our power supply hooked up. Just because I'm being optimistic, let's go ahead and let you see some output. See if we get anything. Here we go. Hang on. I've had this problem before. Well, as you can hear, no joy. We're still not getting to the point where we clear the sound chip. So, let's see if we accomplished anything with the address bus. Okay. Alright, let's look at reset real quick. Oh, that's correct. So we're out of reset. Look at our clocks. They're still there. And here is address 14. See, address 14 wasn't the problem before. Now it is. 13, 12, 11. We're getting nothing on the address bus. So, either I've soldered something wrong, somehow got a bent pin, got a bridge where there shouldn't be, or this CPU is just no good. Huh. All right. Well, I'll tell you what. It's getting to be pretty late at night, and I'm tired. And I'm not going to accomplish anything like this, so I'm going to leave this and come back to it tomorrow. See you then. Okay, so the replacement CPU, this one, didn't give us anything on any of the address lines. It seemed to be getting its power correctly, and it was coming out of reset. However, reset's an input signal, whereas the address lines are output signals. So either this is a defective CPU or it's a fake. Now, I bought this from a U.S. seller, so I was assuming I was going to be getting an original, but it's possible that it's a fake. I'm not going to go to the trouble of using acetone and seeing if it's been rebadged or anything like that. At this point, the only thing that matters is it doesn't work. So what I've done, I've gone ahead and put the original CPU back in because I wanted to see for sure if or whether the problem was my soldering um, of the socket headers. Um, I looked visually, I looked under magnification, and I couldn't see any mistakes in the soldering. So the next step was to put the original CPU back in and see if it's behaving the same way it was um, before desoldering it. If that's the case, if it's behaving the exact same way, then I think we can safely assume that my soldering is correct and it was the old CPU or the replacement CPU that was actually bad. So what you're actually looking at down here in the corner, um, not that I'm trying to copycat Adrian Black, but he made me curious. He ordered recently an $18 oscilloscope from AliExpress, and he reviewed that, and um, it was mostly okay. It didn't quite have the range, or the frequency range that the bandwidth that you would need always to work on these machines. So I went on AliExpress and I found one for $25, the Z-Way-154 Pro. This is just a $25 shipped all the way from China. Um, it's USB-C powered, and it's actually turning out to be a decent little scope. So if you're looking for a scope for your workbench and you don't have a lot of money to spend or a lot of space to take up on your bench, this thing's tiny. I mean, you can see my fingers in comparison here. I'm touching it. It's actually teeny tiny, but it does seem to do the job. So I've got that hooked up, and I am sorry for the glare. I can't do much about that. What you're seeing in there is the little tripod that the camera is on. It's pointing at the little scope. I could probably fix that if I set the scope up on something, but right now it's on the desk. So just to show you, here is power on the CPU, 5-volt power. So there's our 5 volts, and the RMS is reading 4.92. I will switch the voltage base, other way, to 5 volts, and I will show you the clock signal. I'm going to have to adjust the time a bit for you to see it properly. Sorry. Okay, that's our 12-volt clock, and it's reading. Yeah, I don't know how much you'll be able to see that, but the frequency at the bottom is reading 3 megahertz. It's reading that just fine. There really isn't a decent manual with this thing, but it just took me a few minutes to go through the menu system and figure out how to how to set everything. So no big deal there. I'm going to switch the voltage back to 2 volts, and let's see if we can read go a little smaller. Okay, there is address line 14, which looks good. It was fine before and it's still fine now. I'm going to move the trigger a little bit. Okay, for address line 14, which is as it was before. 13, as it was before. 12, as it was before. 11, as it was before. 10, and that's one of the ones that was screwed up, and that's exactly the way it looked before. 9, that's exactly the way it looked before, just held low. 8, held low, exactly as before. 7 is good. 6 is held low, exactly as it was before. 5 is held completely low. There's nothing going on there at all. Address 4, same thing, held low, nothing. Address 3 is fine. 2, held low, just like it was before. 1 is fine, and 0, a lot like address line 10, but exactly as it was before. So I think that I didn't do anything wrong with the soldering of the socket headers, and I think our problem is genuinely I think that the replacement CPU is genuinely bad, and our main CPU is still a question. So I had a thought about that as well. Since our CPU is now socketed, very convenient, I'm going to go ahead and pop it out. I regret doing this because it's very hard to get back into those. I have placed an order for proper 64-pin dual wipe socket that I'm going to replace these headers with, because these little milled pins or milled hole pins are just too much of a pain in the butt. So we'll be doing that. But for now, take the CPU out. And what I want to do is I want to see if I try to drive these addresses, because the address lines are being driven by the CPU. And they're being held down. They're either being held down by the CPU or being held down by something else on the board. So I want to see if I can drive one of the bad address lines with a pull-up to 5 volts and see if I can get it to go there. And to do that, I'm going to use a 470 ohm resistor. This should be adequate to the task. Okay. Now the CPU gets its plus 5 volts on pin 2. So I'm going to go from pin 2. I'm not sure what's going on with 10, why it's sort of squiggly like that. So I'm going to go to 9, which is one of the ones that's being pulled down. So that would be pin 11. So that tells me that our CPU is probably not the actual problem. And our actual problem is probably something else. Now, most of those address lines are on the ROMs. So the ROMs could be our problem. The two scratchpad RAM only connect to address lines 8 through 14. So because we have problems with address lines 5, 6, 2, and 0, those aren't the most likely culprits. The ROMs, these two are, scratchpad RAMs, ROMs. The ROMs attached to address lines 14 down to 3, which leaves out 2 and 0, which are problematic, but we're going to have to find those somewhere else. Those probably going to be somewhere in this logic. The whole problem may be somewhere in this logic, because there is some address decoding that's done. Sort of the equivalent of what the C64 does with the PLA. There's some address decoding in combination with some other signals that determine where chip selects go. So what I want to do at this point, I'm going to put the CPU back in, and we're going to do something that's probably going to bug a few people. Because it's so difficult to desolder and resolder on this board with the traces being unmasked between vias, I'm actually going to try something. I know some people do this and some people hate this. I want to try snipping some pins on one of these ROMs. Now, when you snip a pin, you can put it back together again with a little solder, so it's not that big a deal, but some people do have a big issue with it. In this case, though, like I said, with the problems desoldering and resoldering chips on this old TI board, I think it's warranted. So let me see if I can get this chip back in, and we'll go from there. Okay, believe it or not, I think I got it that time. So, power back up. And let's take a look at the ROMs. Now, one of the oddball things about the TI-99, it has many, is that the ROMs and the scratchpad RAM are hooked up to the backside, if you want to call it that, of the data bus. So the ROMs connect to address lines 14 through 3 on the CPU, and they do it in reverse order. So address line 14 on the CPU goes to address line 0 on the ROM. So if we want to, for instance, snip the leg that goes to address line 9 on the ROM, that would be 14, 13, 12, 11, 10, 9. That would be address line 4 on the RAM, or on the ROM rather. So address line 4 on the ROM is actually pin 4. So here's the notch, pin 1, 2, 3, 4. I'm going to go ahead and snip this. As I said, I can bodge it back together with a little solder if that's not the problem. Oh, let's make sure that, before we do anything, let's make sure that things are working. So let's hook the scope back up and make sure we're still in the same condition we were. Here's our power. Not great. Five volts on the CPU is there. Reset on the CPU is good. Okay, there you can see address line 9, and it's still in that short state. So address line 9, 14, 13, 12, 11, 10, 9 is the 6th, which means it's address line 5 on the ROM. So that is going to be, I believe, pin 5. Let me verify that. address line 5, no, it's pin 3 on the ROM. Glad I checked. So I'm going to go ahead and snip pin 3 on this ROM. There's the notch, so pin 1, 2, 3. And again, I can bodge this back together with a little blob of solder if this doesn't do the trick, and I'll have to check it on the other ROM. So pin 3 is snipped. Here is address pin 9 with that ROM pin snipped. Nope, that wasn't it. So I'll have to fix that pin. And the next thing we can do is do the same thing on the other ROM chip. Okay. So we try again. 9. And do we get anything better here? Okay. I've had this problem over and over again. I've got to do something about this power board. After I decided to give up on this thing for the time being, waiting for the new parts to come in, I went to go ahead and put it away, but before I put it away, I wanted to fix the power supply problem that I was having. And what that turned out to be was the connector that connects to the power supply board that clips onto the pins. The 5-volt line, I pulled that little crimp connector out, and it turns out it was broken, so it was only making intermittent contact. I don't have a replacement for that at the moment. I've ordered something. It's not quite exactly the same thing, but it should do the job, I hope. In the meantime, however, I went ahead and hardwired the power supply board on, and I also took the opportunity, while I had it apart, to color code the wires. TI just put 4 brown wires, makes it harder to know what you're doing, follow your circuits. So I went ahead and put on the correct color codes: red for 5 volts, black for ground, yellow for plus 12, and white for minus 5. And after doing that, it occurred to me that when I tested the address line 9 with the resistor to pull it up to 5 volts, that might have been one of the times that I wasn't getting 5 volts, and I decided to retest. So what I've done is I've pulled the CPU out of the socket again and returned the resistor. The resistor is going from pin 1 to pin, I believe it's 15, which is address line 9. I have also bodged back together with little solder blobs the 2 pins on the ROMs that I snipped, so those are connected again. And if we turn it on and test this time, we should see that that address line is actually being properly pulled up to 5 volts, which tells us that it is not being pulled down by anything else on the board. So here we go. Watch the scope there. And there we are. We're 5 volts on address line 9. That does indicate to me that the CPU, the original CPU, is at least part of the problem with this board. Once we get a new CPU and plug it in, hopefully one that works, we'll see if we get any improvement. Hopefully the address bus will be working right, and then we can move on to testing things like the data bus and anything else on the board, assuming we're still not working at that point. So back to our regularly scheduled programming. Well, I'll tell you what, I have those sockets on order. I also have a couple of replacement CPUs on order in case that is still the problem, which it could be. So I think we're going to have to come back to this when I get those supplies in. For now, we're just going to leave it at this, and we'll make a part 3. Sorry this wasn't more satisfying. Didn't actually get a fix out. But we'll get there in the end eventually. And in the meantime, everybody, if you enjoyed my flailing around here, please go ahead and give the video a like, a thumbs up. As usual, if you haven't already, Please subscribe to the channel. That helps a lot. The like and thumbs up helps a lot. Leave a comment in the comment section below. That helps a lot. If you'd like to support the channel, there are a few ways to do that. You can join on Patreon, and that link is showing up. You can buy me a coffee. That link is showing up. Or you can click the join button, which is right down here somewhere, and join the channel. All those things give you access to a few perks. You can read about those by going to those links. And I don't ask for very much. And of course, you're not required to do that. You can watch my videos without joining or becoming a Patreon or anything like that. Share the video out to as many folks as you can. The more people we get viewing, the better the YouTube algorithm likes my videos, my channel, and that's a great thing. There will be a link in the upper corner to the first part of this video, and once it exists, to the third part of the video series. And I think that'll about do it. So everybody have a great week, and stay safe and stay well, and we will see you in the next one. Thanks for watching. Bye.